Pick up where we left off, number 22. First, you have to decide if you can simplify that on the inside or not, which there aren't any perfect cube roots going on here because that's a cube root. So you cannot simplify that. So then you gotta split it up. So it'd be cube root of 9y to the fourth. And we do actually have a perfect cube with that y to the fourth, but that's okay. We can take care of that in a little bit. Okay? And then on the bottom, we're going to have cube root of 2x. So you have to remember how to rationalize. Okay, when I rationalize, I have to figure out what I can take this number times to make it a perfect cube root. Okay, so what is a perfect cube root that's a multiple of 2? That would be an 8. So how do I turn the 2 into an 8? All right, well, you're going to have to take it times 4. So I take cube root of 4 for sure, and then I have just a single x underneath there. I need 2 more, so I need to multiply top and bottom by 4x squared, cube root of 4x squared. All right, so in order for me to multiply that, it has to be a cube root. And then you got to think about, all right, well, what is this going to give me down here when I simplify it? Well, you have a cube root of 8, which is 2, and the cube root of x cubed, which is x. So you have a 2x on the bottom. Then on the top, we will not be able to simplify anymore except for the y. All right, so y to the fourth right there, we can get one group of those out. So that gives us a y out front, and then we have cube root 9 times 4, which is 36, x squared, and we have that one y that's left underneath there. So that is our final answer after we rationalize, okay? Next page. All right, up on the top, simplify. That one's kind of interesting. All right, so you have the fifth root and the fourth root of x to the 40th. You won't see something like that on the final. It's just kind of an extra problem. So you can think of it like this. So fifth root turns into 1/5. So I would have something like this. All right, and then fourth root turns into 1/4. So that would be this now. I'm going to have a fourth up there and then a 1/5 up there. So think about how exponents work. If you have a power to a power, you're going to have to multiply. So you'll just multiply 40 times 1/4 times 1/5. Multiply all three of those from left to right. So 40 times 1/4, that's 10. All right, so I could rewrite this as x to the 10th to the 1/5, and then 10 times 1/5, that's 2. So it's x squared is your answer. 24, simplify that. You're going to have to factor, all right? So think about this stuff here. That number and that number are perfect squares. So that means that's more than likely going to be a perfect square or a perfect square trinomial, which this would give me 7x in the front. That would give me a 4 in the back, and it's a squared. So a 7x plus 4 squared. All right, and then that's all underneath the radical still, so we're going to have to rewrite that with the radical. So what's the square root of something squared? You just get whatever you have in the parentheses. So this is just 7x plus 4. All right, so that's a simplified version of that one. On to 25. So with problems like 25, you have to isolate the radical, which it already is isolated here, and then you square both sides. All right, when you square that radical, it just gets rid of that square root sign, and you're left with 2x plus 1 on the left, and then x plus 5 squared. You'd have to FOIL that. So it's x squared plus 10x plus 25. All right, so then you should recognize that there's an x squared and an x floating around in this problem. So you got to put everything on one side and factor. So I'll have 0 equals x squared plus 8x plus 24. And then we have to factor and solve. All right, so factors of 24 that add to give us an 8. That would be a 6 times, no, that would not be a 6. 8 times 3 is 24. And 6 times 4 is 24. That doesn't do it. What else? 12 and 2. I don't think this one factors. Let's check the answer key here. All right, so let's see. We are on number 25. So that one doesn't factor. Yeah, that's what I was thinking. So that means you got to use quadratic formula. Okay, and quadratic formula again is opposite b plus or minus square root b squared minus 4ac all over 2a. So we have to plug in our a, b, and c. So that would be a negative 8 plus or minus square root of 64. That'll stay as a minus. Minus 4 times a, which is 1, times 24. So that is 96 over 2. So 64 minus 96 is a negative 32. So I have negative 8 plus or minus square root of negative 32. That's going to give us an imaginary number over 2. Square root of 32 simplifies to this. So it's negative 8 plus or minus 4 square root 32. It would be 4i square root 32 all over 2. And then you simplify what you have by taking a 2 out of everything. So that goes away, that turns into 4, that turns into a 2. So your answer is negative 4 plus or minus 2i square root of, sorry, this should have just been a 2 down in here. 2. So that's your solution. Okay, quadratic formula, you'll have to use that. I'm not sure on the test if you have a quadratic formula, but I will let you know tomorrow. All right, 26. Solve something like this. So how do I get rid of the 1/3? Because we have to isolate that exponential there. Isolate that first. So times both sides by 3. That gets rid of that there. That cancels that there. We got 2x plus 4 to the 2/3 power equals 16. And we actually did one of these in class. So how do I get rid of that 2/3 exponent? You're going to have to use a reciprocal exponent. So 3/2 power. 3/2 power. That'll cancel here. And we get 2x plus 4 equals 16 to the 3/2. Well, that is the square root of 16 cubed. So square root of 16 is 4 cubed is 64. Minus 4, 2x equals 60, x equals 30. Okay, so that's your solution for that one. 27. You're going to have to move this radical here to the other side. So 2x equals square root of 6x plus 4. All right, back to this problem. I had to kind of switch to paper going at home. So what you want to do after you get that square root by itself, you guys know that you should square both sides, like so. Okay. Then when you square both sides, you'll end up getting a 4x squared on the left, 6x plus 4 on the right, because that will cancel with that square root. Then you know whenever you have an x squared and an x floating around in there that you want to put the x squared and the x on the same side. I want to keep this x squared positive. So that means everything is going to the left. Okay? Everything's even, so that's kind of nice. We can take out a 2, breaks it down a little bit, like that. And then you can factor this stuff on the inside here. So there is a 2 out front, there's a number out front, so you're going to have to use smile method for that. Okay? So 0 out there, 2x, and then an x. And it looks like we'll have to put a 2 here and a 1 here because that would give us a 4 and a 1. I can put a 4 and a 1 together to get a negative 3. So negative 4, positive 1. And then your 2 answers come from here. So negative 1/2 is an answer and 2 is an answer. And you got to make sure that you plug these in to double check them. Because if I put a negative 1/2 in here, it looks like it could create a negative, but half of 6, or negative half of 6, is a negative 3 plus 4 is a 1, so that still works out okay. Actually, that gives me a 1 in here, so this would be 2, so when I check that, minus 1 equals 0. That's a negative 1 minus 1 equals 0, that's just negative 2 equals 0, which it doesn't actually, so I was correct in thinking that that negative doesn't work. Okay,
And then if you check the other one here, that would be a 4. If I put a 2 in there, it's 12 plus 4 is 16, so 4 minus 4 equals 0. Yeah, that one works. So that is the solution. That one works. Okay. I did 28 in class for some of you guys. I'm not going to go through it. It's kind of a big problem, so if you don't understand it, that's okay. There's not one on the final like that. And 29 is kind of a larger problem also. I do want to go through some of the inverses, like number 30. Okay. So find the inverse of this problem. You need to first change f of x into a y. Alright, so then you got y equals 16 times x plus 6 squared minus 9. Then remember, for inverses, you just flip the x and y. So that and that switch. So you'll have a x equals 16 y plus 6 squared minus 9. And your goal here now is to get the y by itself. So move the 9 over. So it's x plus 9 equals 16y plus 6 squared. Divide both sides by 16. Okay, those cancel. Then you can square root both sides because you have to get rid of this right here. Alright, so the square root and that square cancel. So over here you might be looking at it and you're like, whoa, I got a fraction underneath there. But remember how you do square roots. You can do it for the top and the bottom. So I can take the square root of x plus 9 over the square root of 16, okay, which is over square root of 16, which is 4, and I have equal to y plus 6. Then the last thing you have to do is subtract the 6. So square root of x plus 9 over 4 minus 6 equals y. Alright? And you could simplify that more and get common denominators, but this would suffice. That would be good enough. Okay? So it's y equals square root of x plus 9 over 4 minus 6. That is your inverse. Okay? That'd be kind of a headache to verify that those two are inverses, but it is possible. Alright, on to the other side here. So same thing up top. Find the inverse of g of x. So g of x is y. Find the inverse of that. So you need to flip the x and y. So rewrite it as x equals 2y cubed minus 6 over 9. Alright? Then you need to get rid of the 9 because we want to solve for y cubed or solve for y here. So times by 9. And you get 9x equals 2y cubed minus 6. Okay? Move the 6 over. So it's 9x plus 6 equals 2y cubed. Divide everything by 2. And I'll just do it over everything. That's okay. You can split it up between all of them or do it under everything. That's okay. And then we have y cubed equals 9x plus 6 over 2. So how do you undo a cube, an exponent? You have to cube root it. Alright, and then you could just leave that since we're finding inverses. It would be y equals cube root of 9x plus 6 over 2. That would be your solution. Okay, so 32, verify algebraically. There's one exactly like this on the test. So make sure you know how to do that. Verify that they are inverses. So what you have to do is find f of g of x and g of f of x. You plug them into each other. You do composites both ways. So this one I'm going to plug into here, and I have to show the algebraic steps after I plug it in. Alright, so that's what it looks like when I take g into f. So 3 distributes. When you take 3 times a third, they cancel. So you have x minus 9 plus 9, and look at that. You'll get an x. Okay, that would be f of g of x. Now I have to do it the other way. So it's going to be into here. So I have 1/3 3x plus 9 minus 3. Third distributes, so 1/3 times 3 is 1. 1/3 times 9 is 3. Minus 3, and bam, another one. Got an x. That's your goal. So to prove they're inverses, they must both give you x. So they're inverses. Alright, so those are inverses down to some of the log stuff here. So use these logs. Boom, boom, boom. Some of you guys have calculators that don't have to use those, but I still want you to use those to show your work. So log base 4 of 9. How can you use 2, 3, or 5 to get the 9? Alright? So you have to use the numbers that you're given in the logs up above. So I know that 9 is 3 times 3. Okay, so I can write it a couple different ways. Log base 4 of 3 times 3. That's inside the log. Okay, or you can write it 3 squared. It doesn't matter. Either way works. Then we also know that if we have multiplication going on inside the logarithm, 3 times 3, we can break it up into 2 logarithms with addition. So then look up here, you have 0.7925 as log base 4 of 3. So you have 0.7925 plus 0.7925, and whatever decimal that gives you, it's about almost 1.6, so it's like 1.5850 maybe. I'll double check it. .85 or 585, yep. Second one, so use the numbers above. Log base 4 of 4/3. Okay, let's split it up first. How can we split up a division inside of a log? That is subtraction. Log base 4 of 4 minus log base 4 of 3. Alright, now there's two directions you can go with this. You can take the easy route, which I would do. Log base 4 of 4, that's just a 1, because anytime you have the base match the thing inside the log, that's a 1. Or you could split the 4 up into 2 times 2, which would be that twice. 0.5 plus 0.5 is 1. So either way. That's a 1 minus log base 4 of 3, which is that, minus 0.7925. So that's going to be 0.2075. Verify with the calculator. Got it. Okay. So then these ones over here, you're going to have to kind of do them similar. So use the numbers that you're given up there. And I would just try to break these down to see what it turns into. So log base 4, how can I use the numbers up above to get these ones? Okay, so 75, that's take out a 5, you get, what is that, 15. And then you can take out another 5, you get a 3. So this would be 5 times 5 times 3. Alright, then the 48, take out a 2 and you get a 24. Take out another 2, you get a 12. Take out another 2, you get a 6. And 6 is 3 times 2. And give myself enough room in there. So this one is log base 4 of 2 times 2 times 2 times 2 times 3, which you can split that up into 5 logarithms. Okay, or you can use 4s, because this would be log base 4, because that's a 4, plus, that's another 4 there, log base 4 of 4 plus log base 4 of 3, because that would be a 1, and then a 0.7925. So it's 2.7925. Okay, that one's pretty easy to do in your head. And then, so you can finish this one with a calculator. I'm not going to. Going down here to some other log problems using some properties of logs. So 34 is 7 to the power of log base 7 of x minus 5. Okay, there were inverse properties that we went over in class. When you have a logarithm in the exponent, if the base of the log matches the base of the exponential, they will cancel. So these two cancel, and you're just left with whatever you had inside the log up there, which is the x minus 5. Okay, I can kind of enlarge that like that. So since you have a log of 7 up in the top, those two cancel, and you just get that x minus 5 there. Okay, which is that. Over here, you're going to have to get rid of that 9th root, or just rewrite it. Okay, so we know square root, something like this. If I did square root of x, okay, that can be written as x to the 1/2, because really there's a little index of a 2 there. So if I have a 9th root of 7, I can rewrite this as 7 to the 1/9. And then remember what happens if you have the base match the thing on the inside, like up above. It turns into a 1, or it cancels out really, because that 1/9 would bounce out front and then would turn to a 1. So this is just 1/9 is your solution. Okay. Over here, kind of use those properties. Log base 5 of 5 is a 1. So then you can rewrite this, log base 8 of 1. And if you forgot how to do these, if you are trying to evaluate a logarithm without a calculator, you don't have it set equal to anything. We don't know what it equals unless we put it in the calculator, and sometimes it doesn't work. We have to set it equal to x. And then you do what we call checkmark method. So 8 to the x equals 1. So what power of 8 will give me a 1? That's a common one that is similar for all numbers. That would be 0. A 0 exponent turns everything into a 1. Okay, and over here, we don't know what it equals. Set it equal to x. Check mark. So 2 to the x equals 1 over 64. How can we change 2 into 1 over 64 as a power? Okay, well, we have a fraction here. So you know that that exponent is going to have to be negative to change this into a fraction. All right, so let's say negative something. Well, how can we get the 2 into a 64? Well, that's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2, that's our 64. So how many do we have? 1, 2, 3, 4, 5, 6. 6 of them. So it's negative 6 is your solution, because 2 to the negative 6 power gets me 1 over 64. Alright, down below. I'm going to kind of bounce around a little bit with the log equations. These two are pretty much the same. The one on the right involves factoring, but they're pretty much the same. You got to remember what you do when you have the same log on both sides. Okay, so on the left here we got log 6 and log 6 on both sides. This only works when there's a single log on both sides. If there are more than one log over here, then you'd have to condense, put it together before you do this. But we can just cancel out those logs because it's the same on both sides. And then you can take the stuff on the inside, set it equal to each other. And then that's fairly simple to solve. So minus 2x plus 11 plus 11. So you get 5x here, and then we get 20 here. So divide by 5, x equals 4. Easy, right? Okay, next page. Ooh, this doesn't work out. Hopefully you can kind of see what's going on here. I might get out. Let me get out the other review guide I got with me. That way you can see it better. Alright, number 40. In order for you to do this, so like I said before, if there's more than one log floating around, you got to condense first. Let's see if I can focus that a little bit better. So, condense first. We condense the logs on the left here. It's log base 16, so it's kind of a large base. But we have a subtraction going on here, so that means these have to divide. So it'll be log 16, 9x plus 5 divided by x squared minus 1. Alright, that's the stuff that's on the inside of the log now. Equals 1/2. So now we have condensed. There's only one log, so you have to check mark method. So 16 to the 1/2 exponent equals 9x plus 5 over x squared minus 1. This, 16 to the 1/2, I showed you guys a little bit ago, 1/2 exponent is square root. That's like this, which is a 4. Okay? So that 16 to the 1/2 turns into a 4. Now we got to start solving for x. How do you get this out of the bottom? Okay, you got to times both sides by it. So times x squared minus 1. Then the 4 distributes to that. So it would be 4x squared minus 1 equals 9x plus 5. Put everything on one side, and then you're going to have to factor. So we're over here. So 4x squared minus 9x You move the 5 over, so it's minus 6 equals 0. Alright, let's try to factor this quick. So, smile method again. If we use a 4 and a 3, that would be a 12. Nope. Let me do some trial and error here. I might have to do another one up here. 2x, 2x, 3, 2. That would be 6 and 4, 10. Not it. 4, 1, 2, 3, and 2. Nope. That gets me 12 and 2. That doesn't work. So, the other option would be the 2 there. I think we might have to quadratic formula this. Let me double check here. 4x squared minus 9x minus 6. Yep, you'd have to get this with the quadratic formula. Let me see if I can use my graphing calculator to get you a 0 here. No, you have to use quadratic formula. Okay, so that would be good enough for now. Quadratic formula. So take some time to do that. Bouncing on to the next one here. So we have 5 to the 3x, 4 to the x plus 3. We did one of these for the bell ringer today, and this one's kind of a harder one, so I just kind of get it started and you can finish it. You're going to have to take the log of both sides because we can't get 5 and 4 to have the same base. So I have the log of 5. I can put the 3x out in front, and then over here I'll have x plus 3 out in front of a log 4. Okay, because I would take the log of 4 here, bounce the x plus 3 out front, and then we're on to this step. So since there's an x here and an x here, what you're going to have to do is distribute the logarithm. So that goes into there. 3x log 5 equals x log 4 plus 3 log 4. Put this and this on the same side. Alright, so it'd be like this. 3x log 5 minus x log 4 equals 3 log 4. Factor out an x. X goes out front. 3 log 5 minus log 4 equals 3 log 4. Then divide by the stuff in the parentheses. So 3 log 5 minus log 4. That's what we're dividing by. And this is our solution. Kind of ugly, but if we wanted an exact solution, I could just leave it like that. Otherwise, you'd have to put it in your calculator and estimate to the 4th decimal place. Okay, a few other logs here. Probably won't finish this, but I'll just kind of go through a few of the logs. Those are the ones that people have the problems with the most, and I can kind of spend some time on the graphs. Okay, so this one right here, you got a few options. You can check mark it right away. However, you see that cube up there. I would put that in front. Alright, so I would write it with the 3 out front. Like that. And then, since this is out front, I can divide both sides by 3. And that really simplifies it, because you don't want to FOIL that out. That looks like a headache. So 6 divided by 3 is 2. Now we check mark. So 4 squared, that's 16 equals 5 minus x. Okay, and then since there's a negative x, you got to do a little bit of brain work here. I would subtract the 5. That gets me to an 11. That's 11 equals negative x. So then you change your sign so it's x equals negative 11. Okay. And when you look at it here, you might think a negative doesn't work because it's a log. If I put a negative 11 here, that's 5 minus negative 11. So that is a double negative, which canceled out. Okay. 43, you need to bounce these up before you do anything. Okay, so 64 to the 1/3 power. So I'm going to rewrite this. Log base 9 of x equals log base 9, 64 to the 1/3 power. Okay, I'm just going to kind of write it in the corner here. That is essentially the same as a cube root of 64, which the cube root of 64 is just a 4. Alright, so then this one would go up here, 1/4, which is 4th root of 81. That's a 3. So log base 9 of 3. Okay, then you got to put this stuff together. So it'd be log base 9 of x equals log base 9 of, so plus, what does that mean again? So plus means multiply in log language. So you get that. Then you got log 9 cancel, x equals 12. Not too bad. Just looks pretty terrible. Okay, 45 here, condense the expression. That means put it back together. You got natural log of x plus 3 natural log of y minus 2 natural log of z. So you have to kind of, we've been condensing a little bit already, you just have to remember what you're supposed to do with each one. So plus means multiply, but first you got to bounce these up. Okay, so it's natural log x plus natural log y cubed minus natural log z squared. Then, now we can start condensing. So it all turns into x times y cubed divided by z squared. So that is your natural logarithm. Okay? A few graphs. So down below here. This is an exponential growth function. We know it is a growth function because the base is larger than 1. Okay, if it's a fraction, then it's a decay function. All right. To graph this, you could use your generic points: -2, -1, 0, 1, 2, 3. But remember, you want to try to keep this exponent small. So the first number that you would probably want to use would be like a -3, which I'll show you. If I use a -3, that would give me a 0. 2 to the 0 is 1. Minus 3 is -2. And the reason I put it in the middle of my XY chart, because that's the first number that I want to use to get that 0. So then I can just kind of use all values around that to fill in the rest of my chart. Okay? Domain, since I can plug in whatever I want. Domain is all real numbers. Range, you have to find your asymptote. The asymptote comes from the number on the back end for these. So the range is going to be y is greater than a -3, and it's not greater than or equal to because remember they're asymptotes here. Okay, so that would be on my graph right here. That would be my asymptote right there because of that -3 on the back end. So below y equals -3 as an asymptote, and end behavior. We haven't done that in forever. I'm not going to have it on the test, I don't think. So it looks like this. As x goes to -infinity, what does f of x do? As x goes to positive infinity, what does f of x do? Okay, so -infinity would be this way. F of x is going to get close to a -3 because it gets close to this asymptote. And we haven't done one of the end behaviors with these before, so that's why I'm not going to have it on the final. And as I go to the right, this is where, since it's a growth function, it would kind of level off down here to the left, but then it would kind of shoot up this way, and you would see that with your XY chart, so that goes to infinity. Okay? Alright, getting there. So, up here, graphing log functions. Alright, so we haven't done one of these in a while. How do you graph a logarithm? Remember what things you cannot have in logarithms. You cannot have a 0 or negatives. Alright, so the first thing I want to get in here would be a 1. What number can you put in here to get a 1? That's one option. The other option was check mark it. You turn it into an exponential function, and then we plug into the y. That's what I did in class. So it's kind of like a backwards check mark. So we kind of go from the 2 to the y. So 2 to the y equals x minus 3. I didn't really need to put that in parentheses. I did that unintentionally. And then we move the 3 over. That's the function that we have to graph. 2 to the y plus 3. Then you can plug whatever you want in for the y value. So you use your generic points in the y, and then that'll give you the shape of the graph. Domain, remember we get our asymptotes from here. So it's going to be x is greater than 3 for the domain. Range is all real numbers. Asymptotes, so x is greater than 3, your asymptote will be x equals 3. And end behavior, I'm going to forget about it. Alright, so my asymptote would be over here. And your graph would look kind of something like, am I going to go above the y-axis? It would be 0, 4, 0. So it would hit there and it would go above the axis like that. It'd probably level off a little bit more than that, but that's what they kind of look like. 49, I'm going to skip this one, but remember, oops, I did 48, got to do this one. Parent function here, write the equation for the function after each of the following transformations. You won't have transformations on there, I'll skip that one. 49, graph that, that's a decay function. Because of the fraction here, that's an exponential decay. So that one's going to go down, so you'd have a negative 4 asymptote, and at 0, 0 plus 2, that's squared, that's 1/9 minus 4, that would be, it's kind of really close to this, so it's going to probably be something like this. Alright, and you could fill in your XY chart. Since we have a plus 2 up there, I do these points for my XY chart. Alright, number 50 is an exponential growth equation. I think for the next 11 years, 12 more parakeets were observed per year. So 12% more is the word that tells you it's a growth function. Okay, so we started with 1219. So an exponential that shows growth function. So A is the amount in the end. P is your initial amount. So it's 1219. 1 plus or minus r is a growth. So it'll be plus 0.12. So it's 1.12 to the t. That's over time. In 98, so that would be how many years from 92 to 98? That would be 6 years. So I would do this to the 6th, plug this in your calculator and get a value. Okay, and then this one right here, in what year were there 1712 parakeets observed? That's more important because this is the one you're going to have to find. You're going to have to solve for an exponent. Okay, we have to solve for that t and figure out what it is. By doing that, we have to use logs. Okay, so 1712 is the final amount. And then 1219 was our initial amount, 1.12 to the t. That's what we're trying to find. Okay, so divide both sides by 1219. You get this. I'm not going to put it in my calculator at the moment. All right. So then I would have 1712 over 1219 equals 1.12 to the t power. You got to log both sides here, because I want that exponent down. Okay? Then that t would go down, and to get my final answer, I would have to divide by the log of 1.12. So putting it in your calculator, you would put this in there, log of 1712 over 1219. I would divide that by log of 1.12 to get a rough estimate of the answer. And I guess I will put that in my calculator just to kind of make sure you did it right. Oops. Log of that. Log of answer divided by log of 1.12. And you get 2.9968. So we'll say it's about, we can say about 3 years. Okay? Because it'd be 2.997, which 3 years sounds better. Alright? So here's where, since we had that variable in the exponent, you'd have to use logs on both sides to get the variable down out front. Okay? So this would actually turn into t of log 1,2 there, which that's why I divided it here. Okay? Alright, more exponential growth and decay, XY chart, points of discontinuity. I can do that one fairly quick. So that's number 53. So you're going to have to factor the top and the bottom. X plus 5, X plus 1. Then you look for things that cancel, so that X plus 5 will cancel. Remember, when you have a factor that cancels, that's a whole. So a whole at X equals negative 5. And then that right there is my other point of discontinuity, so that's a negative 1. So that's asymptote at X equals negative 1. So those are the points of discontinuity. Okay, simplify that one. You should be able to do that. Just multiply straight across and then simplify from top to bottom. I'll take care of these last two graphs here and then call it good. Should be able to handle the rest of those. The graphs were harder. So here, remember our rules. So that's a 3x squared. This is number 55. 3x squared over an x squared. So they match. So you look at the leading coefficients. So that's 3 over 1. So that's a y equals 3 asymptote. And then we can look down here. You can factor that. X minus 4, x plus 4. So there's a lot of asymptotes going on here. So you're going to have a x equals 4 and negative 4 asymptote. So that would be all of these. So going across. And then I go down here. And I go down here. Alright. So vertical asymptotes, that's the x equals 4. X equals negative 4. Horizontal, y equals 3. X intercepts, so that's where y equals 0. We could solve for that one. Oops, sorry, that's false. That's where, yeah, that is where y equals 0. Okay, and we can get that with an XY chart. Y intercepts, that's where x equals 0. If I plug zeros in here, you're going to get a 0. So your y intercept is 0, 0. And domain and range are probably going to be all real numbers, okay? Because you can plug in, well, all real numbers, excuse me. So domain is all real numbers except x can't equal 4 or negative 4 due to the asymptotes. And the range is all real numbers except for y can't equal 3 because of the asymptote. Okay, which I think that this actually, it will go through here. Let me look at a graph quick. So you kind of have to use a graph to see that. Yeah, so the graph kind of looks like this. So when I do my XY chart up 2 points here, I get this, and then I go here, and I get that, and then I go here. So that's what the graph looks like. So the domain and range is actually a little bit more difficult than intended to be, but that's okay. You don't necessarily need to know that on the test. Here, the one down here, the main thing with these is just finding your asymptotes. So the degree of the top is a 1, degree of the bottom is a 2, so that means you have more x's on the bottom, so I have a y equals 0 asymptote. And then this bottom piece factors to x minus 3, x plus 3. So this one's kind of a bear again. We're going to have negative 3 and 3 as asymptotes. Those are my vertical. And then my horizontal is at y equals 0, so I can draw all those. Look like this. And then a 0. So then x-intercepts, plug in a 0 for the y. It'd be negative 4 over 2, so x equals at negative 2, 0. And then a y-intercept, you plug in a 0 for the x's, so 0, 0. It's 4/9, negative 4/9. So 0, negative 4/9. So that would be 0, negative 4/9. That would be down here. X-intercept is negative 2, 0. So my guess is that the center portion kind of goes like this. And then the outsides will probably go like that. But I can double check here. So 2x plus 4. A tip for all you graphing calculator people out there, make sure you put your top and bottom in parentheses like that when you put it in your calculator. Otherwise you'll get the wrong graph. Oh, they're opposite. So that one's not there. My bad. So it goes down this way, and then it's this way. That's what my graphing calculator shows. Okay, but the big thing are the asymptotes here. So you have to remember, if the top degree is smaller than the bottom degree, then you got a y equals 0. And then you always get x equals asymptotes from your denominator. Okay, the one up here, our degrees were the same. They were equal. So x squared, x squared. Then you look at the numbers in front, which is a 3 and a 1, and you just make them into a fraction. So 3 divided by 1, that's just a 3. Okay. So I'm going to stop there. Hopefully this helps. If you guys get some time to watch it, it's kind of late right now. So come in the morning with questions if you have them, and good luck on the final.